Hello, scientists. My name is Mr. Frills. I'm the principal at KIPP Wonder Academy here in St. Louis. Welcome to Room 9, our region's largest classroom. Today, I'll be teaching science for second grade, but learners of all ages are welcome to join me, and I'm so glad you are here. Let's see what we can figure out today. Today, we're going to be building our ideas around properties of materials. So last week we've been talking a lot about materials. We've been talking about the properties that they could possess. Properties such as like texture or color or flexibility, for example, or even shape. Those things are properties of the material. Last week we talked about a pencil. And with the pencil, we looked at specific materials like the paint of the pencil. The property of the paint was the color of it that was yellow. Another thing we talked about was the eraser. The eraser's shape was pink, but the texture was smooth in the way that it felt. The shape was a square. Those things were helpful for us to identify and describe the material that was being used. Those are properties. This week, we're going to spend time talking about and focusing on how materials can change. We'll figure out if materials can change, and does that mean that they are changed forever or not? So let's start with a question. Have you ever eaten an egg before? What did the egg look like? Were the eggs scrambled? Were they fried? Were they hard-boiled? Or something else? When I make eggs, I notice that when I crack it and put it in the skillet, it comes out liquid, but as it cooks, it becomes more solid. That way I can eat it. Have you ever wondered why it does that? I've wondered why it does that. Can an egg go back to liquid again once it's been cooked? I don't know if you've seen it, but the next time you have eggs or somebody in your house has eggs, be sure to notice and see what happens. I don't know if it can go back to liquid, but I wonder that about all the properties that become liquid and then can they go back to solid, or become solid and then go back to liquid. Today we're going to learn about some ways that materials can change. First, we're going to look at these. I'll show you here. This is just a teeny weeny little candle. Just a candle. We'll be looking at this to see what comes of it. We're going to be doing a little experiment. And with our experiment, there are a few things that we want to know. But before we do the experiment, let's familiarize ourselves with the scientific process. With the scientific process, the first thing that we do is that we ask questions. When we ask a question, just one question, when we ask that question, we're trying to figure out something. We're wondering about something. After we ask the question, we learn all that we can using our senses. We use our sense of smell, sight, touch, taste, and feeling. Let's try it again. Smell, sight, touch, taste, feeling. We can use all those things to explore the question that we asked. And once we've done that, then we can move toward making a hypothesis. And a hypothesis allows us to make a detailed prediction of what might happen. So we'll take a really specific guess to say this will happen when this happens. Next thing we'll do is we'll plan to do a test. We're going to record our data, and then we're going to draw a conclusion. We're going to decide if we were right with our hypothesis or if we disproved our hypothesis. We're going to spend time doing those today. So using our candles, we're going to do that to figure it out. So the thing I have for you, the question I have, is when we look at the material that we have in this candle, we have the metal around it, we have the wax on the inside of it, and then we have a wick on the inside, the thing that lights the candle, the thing that gets lit when we light the candle. I want us to take a moment to think. When I light the candle, what's going to happen to the wax? When I light the candle, what will happen to the wax? When I light the candle, what will happen to the wax? That's the question I'm asking myself today. When I light the candle, what will happen to the wax? But I want you to take a moment to think. What do you think is going to happen to the wax? Take a moment to think. What do you think is going to happen to the wax? There's so many things that could happen. It's material. There's some fire next to it. What do you think is going to happen to the wax? What I like to do is I like to make a chart. And when I make a chart, it helps me figure out all the things that I could be thinking about. So let's see. How will the materials change when we light the candle? And it seems like there's a lot of materials, right? Not just the wax. We have the metal on the outside, little bitty metal, tink, 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 tink. We have the wax, and then we have the string in the middle. We should think about what all those things, what's going to happen to all those things. Let me take a moment to make my chart, and then we can get back together. Let's get the materials. Got it. So I have my materials, and I've set it up to say the metal, the wax, and the string. I want to know what happens to the metal, the wax, and the string. So here's my question. You probably were thinking about the wax. Let's think about all the materials. How will the materials change when we light the candle? How will the materials change when we light the candle? So I think that the metal will stay the same. Here's my hypothesis. Stay the same. I think the wax is going to melt to liquid. And I think the string is going to burn but stay solid. Burn and stay solid. Great. Those are my predictions for what will happen. What do you think will happen? What do you think will happen when we light the candle? What do you think will happen to the materials? Take a moment to think. Do you agree or disagree with my hypothesis? Do you have one of your own? What do you think will happen to the materials? So let's think. Before heating, the way that our materials are set up, before heating, we have the metal that is hard, the wax is solid, and the string is white and solid. If we have to describe it all. So now let's think what happens to it. Are you ready to try to light the candle and see what happens? Before we do this, the thing you should know is that you would never light a candle on your own. You would only do it around an adult. You never light a candle on your own. You only do it around an adult. So right here I'm taking my match. I'm going to rub it and light it. Here we go. The fire is lit. Shake it out. Put it down. All right. Let's hope it stays lit. There's a little bitty flame there, you can see it. And as the fire is burning, I'm just taking observations of what's happening. As the fire is burning, I'm taking observations of what is happening on my flame here, on my candle. So I'm going to put this candle down. And I've had another candle that's burning as well, but it's been burning a little longer to speed it up just a little bit so we can see what happens. I'm going to take this dish that's empty and clear, nothing in it. And what I'm going to do is I'm going to see what happens to the candle if I tilt it to see what happened to the wax. If my hypothesis is right, because I said it will melt to liquid, if my hypothesis is right, that means that the wax will be able to end up on here and it'll be liquid in this dish. It'll be liquid in this dish. Let's see what happens here. I take the candle and I tilt it over. Oh, and it is liquid. You can see the liquid here. But there's something else that's happening that I didn't know, that I didn't suspect would happen. What happened is it turned liquid, but then once it got away from the flame, it turned to solid. As you can see, it's not running. I can't shake it off. It's not going anywhere because it's back solid again. Let's see. I wonder if I did it again, will the same thing happen? If I kept my candle lit and I poured it on the dish, I wonder, will it stay the same this time as well? Let's see. Get my candle. See my dish. I'm gonna pour it in an area that it doesn't have any. See if we can get it in this area right here. Poured, and it's there. And let's see what happens. Oh, the same thing happened. It ran, dripped, and then it stopped because there's no candle left for there to keep it warm. So as a result, we now have dried candle wax. So let's look back at my hypothesis, because now I want to draw some conclusions. I'm going to first blow the candle out though. Not even my birthday. Here we go. So I said the candle wax would melt to liquid. I think that was right. So I'm going to put a check by that. I said that the metal would stay the same. Check by that. And I said the string would burn and stay solid. It looks to me like the string is still solid because I can light it again, and that it did burn because the fire was on it. So I got the string part right. The one thing I didn't think about though, I didn't think about that the wax would turn solid again once it was away from the flame. So I think partially my hypothesis was correct, but I think there was more to it that I should have kept in mind. So I have the wax part partially right, and I tried it a couple times to see if it worked. So let's think about it. The material changed, the wax material changed when it got by heat, when it was heated up. And then it changed again when the heat was away from it. It went from solid to liquid and then back to solid. It wasn't able to move again. Let me see if I can just pick some of it up and see. Because it really is solid. I'll see if I can show you. You can hear the wax moving around there. If I picked up a piece here and dropped it, you can hear it there. It's solid and it is there. That's interesting. I have a couple books that I want to read to us that will help us understand a little bit more about the materials that we have. Are you ready for a book? If you're ready for a book, say, oh yeah. Say, oh yeah. Ready. Perfect. The book we're going to start reading is called Changing Matter. Changing Matter. Sorry. It's called Changing Matter in My Makerspace. It's called Changing Matter in My Makerspace. Here we go. Which state is it? Now, if you're thinking state means like something like Missouri or Kansas or Illinois, that's not what state means in this space. State means how it is in its current being. How is it right now? The state that it is. It's not always easy to spot the state of matter. Sand can be poured, and it can seem like it takes the shape of the container. But sand is not a liquid. It's made of many tiny rocks. Each rock keeps its shape, the shape as it's poured. Interesting. So there are different types of different types of states of matter that it could be. Let's see if we can learn more about that. Temperature changes. Matter can change states. What happens to a snowman when it gets warm outside? It changes into water. Snow is a solid that melts. It turns into a liquid when it gets hot enough. Chill out. You can also change matter by cooling its temperature. Many liquids have a freezing point. This is the temperature at which a liquid becomes so cold that it turns into a solid. A chocolate tree starts out as solid. It cools into a solid inside its mold, and that gives it its shape. Ice maker. Freezing liquid water forms solid ice. It can become anything from ice rinks to ice slides. Some makers use ice to create sculptures. These figures can be any size or shape. Each icy part is carved or made in a mold. Wow, look at all those pieces. So that means that temperature can make something solid go to liquid and something liquid go to solid. All those things are possible with certain types of material. If I were to warm up some things, everything doesn't seem to be able to change because of temperature. Let's read more about it. Heat it up. Solids do not change all states the same way. Rocks stay solid at temperatures that melt ice. It takes a lot of heat to melt rocks. The temperature at which a solid melts depends on the materials it's made up of. Beneath Earth's surface, there's extremely hot melted rock called magma. It sometimes comes above Earth's surface when a volcano erupts. Non-melting solids. Other solids do not melt at all. How does heated wood change? It burns. Other natural materials rot in heat. So let's think about it. There are some things that just rot when the heat comes. There are some things that just melt when the heat comes. Each material has its own reaction to temperature. Some material melts right away, depending on the temperature, like the wax that we had in our candle. But when you think about rocks, it takes a much hotter temperature to get the rock to melt. So materials react differently to temperature. Wood, however, is a non-melting solid. For example, like my desk or my shirt. If they were to be really heated, they would rot. They would burn up and they would not melt. Let's see if we can learn more about this. Can it be undone? Changed forever. Some changes to matter cannot be undone. Picture what happens when bread is toasted. It can be untoasted. The way it looks and feels is changed forever. Other solids rot or break down over time. A squishy black banana peel will never become firm and yellow again. Like our banana peel. Explore it. Take a walk outdoors to explore how matter changes in nature. Find plant matter, such as leaves or flowers. How do they change over time? Do they break down? Look at their shapes. Note if they curl up or change size. See if they stay the same color. How do they feel? Do they break easily? Now is the perfect time to see leaves outside. Their matter has changed. And as a result, their shape has changed, their color has changed. There's so many properties about them that have changed, the way they feel, how durable they are. And as a result, those materials are now different. But it's only different because the weather has changed. And that matter is changed. Can it be undone? It can't be undone. The trees just grow new leaves, and the leaves that are on the ground or the leaves that are dead or like crumbly, those leaves won't go back to being green anymore. That's just how it works. So now we're going to read a little bit more about from a different book. I think it's important for us to learn a little bit more about what is solid and what is liquid as we go. Here we go. The name of the book is called States of Matter. So again, not like states like Missouri or Kansas or Illinois. States as in like how is it in the moment that it is. One state is called solid. What are solids? Many materials are solids at room temperature. From French fries to your favorite shoes, a solid can hold its own shape. If you poured water from a tall glass to a short glass, the water shape would change. But a solid ice cube would keep its shape whether it was in a glass or in an ice tray, or on a plate in the freezer. The container has to be in a cold place. A diamond will always look like a diamond. You could grind a diamond into powder, but if you looked at that powder under the microscope, you would still see solid pieces of diamond. So solid is solid. Can you name something in your house right now that is a solid? Let me see if I can look around my space and see if I can find something that's a solid. My toy car is a solid. My cup is a solid. My clock is a solid. My books are a solid. Do you have something in your house that's a solid? Let's keep looking. The next thing we have says, what are liquids? Your blood is a liquid. So is the water that you drink. Liquids have something in common with solids. Liquids, like solids, take up a certain amount of space. If you pour water from a small bowl into a big bowl, the water will not grow to fill up the space. So liquid is like water. Water is liquid. It goes into the shape and it changes its shape. If it was in the bottle, it'll be the shape of the bottle. If it's in the cup, it'll be the shape of the cup. Interesting. Solids to liquids. Did you ever leave a box of crayons on the dashboard of a car? What happened to them? Most likely, they melted. Solid matter became liquid matter. It had a change of state. This change of state happened because of the change of temperature. The sun coming through the windshield made a waxy crayon melt. Many solids, when heated, will melt and become a liquid. Some solids melt at a lower temperature than others do. The temperatures at which solid substances melts is called its melting point. When a liquid cools, it may freeze. This temperature is the freezing point. How does the heat make a substance change states? Heat is energy. When heat energy is added to the solids, the particles of the solid have a bit more room to move, and they can start to spread out. With enough heat, their particles can move around enough to flow as liquid. Interesting. So the particles of the thing that's melting become so loose, they become liquid, as opposed to when they're really hard and solid and frozen, they become solid and rock hard and they can't move. But the warmer that they are, the looser they become, and they become just like liquid. Just like what we know. So we've learned a lot. Let's recap. So we've learned a lot today. We've learned about materials and their properties, and we use that information about the properties of if it's the types of properties like the shape, the size, the texture. We used our understanding of those properties to determine if materials changed. The way we did that was exploring it with our candles. We used the scientific process to figure that out. The first thing we did was ask a question. When we asked the question, we had to then use all of our senses to observe what we learned about that thing. Once we used our senses to observe as much as we could, our sight, our smell, our smell, our hearing, our taste, or our touch. Once we did that, we were able to make a hypothesis. I made a hypothesis about all the materials on the candle. I made a hypothesis about the metal, about the wax, and about the string. And I was almost all the way right. And I know that because we did a test. We took our candle and we lit it, and we were able to pour it into our Petri dish to then see what happened to the wax. The wax was liquid when we put it in the Petri dish, but then it quickly became a solid as we went on. And we didn't just stop there, because good scientists never do. We did the experiment one more time to make sure that we had it right. And we saw the same thing happen. The wax, when heated, poured into the Petri dish as a liquid, and when we removed the heat, it became a solid again. That's what we learned. After we did that, we recorded our data and saw what happened, and then we were able to draw a conclusion. about if we were right with our hypothesis or if our hypothesis was incorrect. Our hypothesis was partially correct because I didn't know that when it became a liquid, it became back to being a solid. That's something I learned today. I just didn't think about it. Who knew? In all of this, we learned that matter is all made up of all the things that we use. And in the states, there are several states of matter, and we talked about 2 of them today. The first is liquid. The second is solid. When we talked about the solid and liquids, we know that solid is when something is not a liquid. It is able to be held, it holds its form, just like an ice cube. If we put an ice cube on a plate, or ice cube in the tray, or ice cube in a glass of water, it all stays the same. It doesn't change its shape. That's a solid. Our solids are all around us. My desk, my computer, my shirt is a solid. We also learned about the liquids. Liquids change shapes based on what they have. They'll change the shape of a bottle when we pour it in that. It'll change the shape into this when I put it into my cup. It'll change the shape when I pour it out into the water, pour it out into my desk. It'll take the shape as whatever it is. And as a result, the molecules inside, the particles inside of it are so loose that they're able to move around so much. We also learned that the temperature can affect many things. It can either make things melt, or it can make things rot. And every material has a different reaction to temperatures, whether it is cold or hot. If it's really hot, it can have an impact. If it's kind of hot, it can have an impact. For the wax, it only took it to be kind of hot for it to melt. But the temperature that it took to melt the wax would not be the same temperature that it takes to melt rock. So everything has its own reaction in that way. So you have to keep that in mind. There was so much learning that took place today, and I'm sure that you guys are sticking with me because you're scientists and you're able to keep it all in your brain. We figured out that adding or removing heat causes matter to change, and some changes are reversible and others are not. So keep that in mind. But now as you explore the world around you, think about it. What's changing in the world? The matter that you see? And will it be able to go back? Who knows? You as a scientist will be able to figure it out. Look forward to seeing you guys next time. Have a good one.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.